All right, everyone's good? All right, well, welcome everyone. So I'm here to talk about Redfish for data center facilities. So I'm Mike Ranieri from Dell Inc. I'm one of the senior principal engineers. I lead firmware projects. Jeff Otter couldn't be here today. He is a distinguished technologist from HPE. He's contributed a lot in this space, and I've been helping him out on the side. So first of all, why do we want to consider Redfish for the DCF project? So one thing to consider is that Redfish is already a widely adopted standard in the IT space for BMC, servers, storage management, and OCP is requiring Redfish support on many of their hardware projects, in particular the hardware management project for servers. For more information on Redfish, you can always go to redfish.dmtf.org. That gets you a link to all the developer resources for helping you understand what Redfish is. Part of the why for Redfish for DCF, Redfish already defines a lot of the common housekeeping types of functionality that you might need to consider. So when you think about setting up user accounts, how do I do eventing? How do I update firmware? How do I discover systems? How do I get messages or logs? That's already defined in Redfish and doesn't need to be recreated. And so what we really want to look at is trying to create a common data model for both power and thermal types of management to enable software to work across all the different classes of products. For folks who don't know, there's been some data center equipment that's already contributed to Redfish and been standardized. So the work has been going on for years now. Back in 2019, we have the first facilities model that was introduced in Redfish that also included how do you model PDUs, so things like rack PDUs. How do you model your power domains in a facility? We also introduced our common sensor model for giving any sort of reading that you might envision. That's been extended over the years to incorporate new reading types as there have been use cases identified, but overall the general structures remain the same. More recently this year, we've introduced new classes of products to support new types of power equipment, so in particular power shelves, electrical buses, how to represent electrical connectivity between the different types of products that you might find in your infrastructure. We also created what's called a control model. So if you have set points that you need your different little actuators to try to reach targets for, that's all incorporated, and it's heavily based on the existing sensor model that's been added to Redfish. So more recently, the DMTF has published what we call work in progress publications for new extensions to the model. In particular, what we're looking at now for data centers would be UPS types of devices or other types of backup power systems, cooling distribution units, and liquid-cooled servers, so any sort of internal type of cooling capabilities that go beyond just simple fan management. Now, before I go on, the following material is considered work in progress from the DMTF. What that means is that it's not standardized. It's been approved for public release so that other folks outside the DMTF can review it and provide feedback. That's really the important point, is collecting feedback on this material, since not everyone in the Redfish forum is a subject matter expert in this space. So getting that industry feedback is very critical for fine-tuning the model. Because it's a work in progress and not a standard, we may change it over time. It may change drastically once it becomes a standard. Maybe there's very minimal that needs to go through, but just keep that in mind that it's not set in stone at this point. So at least looking more at what we're proposing for UPS modeling, what we really want to do is extend the existing model that we put in for PDUs, since they are rack-mounted power devices. Maybe they're large and they don't fit inside of a rack, but they're still a piece of power equipment with outlets, circuits, and other types of power monitoring. So the additions we need to consider for this is creating what we're proposing as an energy storage subsystem. So how is energy stored in your UPS? Is it batteries? Is it flywheels? Is it supercapacitors? Could be anything. Having the control and monitoring for those types of devices on top of that. The other thing that we need to add in to support UPSs is how do we have to represent the charging subsystem? So any sort of metrics associated with how the charger is performing. Is it degraded? Are there multiple charging units? Is there redundancy in the charging units? How are they fed from the outside world? And then lastly, we need to define standard messages for the common types of events that people care about for monitoring UPSs. So are things like, are there certain faults that need to be emitted? Are there changes in the configuration that need to be monitored? Largely, right now we're looking at existing SNMP traps for creating these messages, but we'd want to have a standardized message registry so that way clients monitoring these events can get consistency across different vendors. So at least from a resource modeling perspective, this is how we're proposing putting all the different resources for the UPS model. So in the upper left, we have our Redfish service route, so that's your entry point for finding out what the manager or BMC is exposing through Redfish. We have our existing power equipment resource beneath that, which then describes what types of power equipment are monitored by this manager. And in there's a new collection that we're proposing for putting our UPSs. So we're adding a UPS collection. So however many UPSs are being managed by that service, you can add that in there. And then for here, we're showing a single UPS just to show how everything maps together. We have our source circuit collection for representing what is feeding into this UPS from the outside world. We have our outlet collection to show what is going downstream of this UPS, showing how it feeds into the different branch circuits that this UPS might be backing up. What's new here is we have the three areas on the right that are additions to the existing power equipment model. We have our electrical converter collection to show the different types of components that might be of interest for managing. So whether it's a rectifier, an inverter, or a bypass type of circuit, that might be necessary to monitor and manage. And maybe it's fruable and you can replace it. You have your charger resource to represent all the types of charging metrics associated with the UPS. And then lastly, you have your energy storage collection, which shows the different types of modules that store energy for providing power to equipment in the event of a power loss. Moving over to cooling distribution, this is much this is a much newer space that we're getting into, but we're trying to leverage the same type of design pattern that we've implemented with the rack PDU model, where it's you have a set of power equipment. So in this case, it's a set of cooling equipment that is being managed by your manager or BMC. We want to look at supporting different types of form factors. Maybe there's different classes of cooling equipment that we need to categorize. One of the things we need to add in here is showing the relationships for what liquid feeds into these cooling systems. How does it feed out to your southbound types of equipment for cooling things downstream? So we're proposing to calling those cooling loops primary and secondary, where primary is what's going into the cooling unit and secondary is what's leaving the unit to all the different servers. As part of that, we'd also need to add new model extensions for representing the pumps that go within the cooling equipment, and also how do you detect leaks? So what's the right way to report outward for when a leak is detected? At least stepping through kind of how this would look in a rack and kind of mapping the terminology together. So I mentioned we have a primary cooling loop that feeds into your rack cooling distribution unit. So that box on the left is just kind of a big rack. You have a big loop that's managed by your facility that's feeding into the cooling unit. And then leaving the rack seat is your secondary cooling loop, and that feeds the liquid to all the servers within the rack. So each type of piece of equipment will have what we're proposing calling a loop interface to show the relationships of how each of the pieces of equipment map to the different loops and ultimately back to which cooling distribution unit is providing the liquid capabilities for the system. So looking at it from a Redfish perspective for how all the resources map together, again, like with the power equipment, you start with your service routes, and then we're adding a new cooling equipment resource to show, and that's going to be your place for finding all the cooling equipment that your system might be managing. At least as a starting point, creating a rack CDU collection. And then in this case, we have we're showing a single cooling distribution unit, so it's really a rack-mounted cooling unit. This could be extended over time if there's other types of cooling equipment. Maybe it's a chiller or a cooling tower. We can add additional collections that are heavily based on this model to highlight the different classes of products. Going into the rack CDU, you have your main circuit collection to show what is powering the equipment. And then at the bottom, we're showing the different types of loops that are affected, that the CDU affects or they're affected by. In this case, we have a primary loop collection where it shows that it's being fed what we're calling, in this case, it's a facility loop interface to show that it's being fed from the main facility cooling loop. Maybe you have multiple primaries because you have redundancy involved, but the names are not something that are set in stone here. You also have your secondary cooling loops to show what is going out of this CDU. In this case, we're just showing one loop interface. It's a rack number 7's cooling loop, and so likely that will go out to all the servers in rack 7. Additionally, there's internal componentry that might be of use to be monitored. So if pumps within the CDU, filters, so having different types of resource collections to show that those different types of components. Maybe there's metrics associated with them that we need to care about, such as maybe a filter is too dirty. Maybe it's going to raise an alarm that you need to replace the filter. So I'm going to switch over to a web browser to walk through some of the mock-ups, just so you get a better sense of what the payloads will look like on a service. All this is available from the DMTF website, so that link, redfishdmtf.org, Redfish Mockups v1, it has links to the different mockups we're proposing. So, good. So if we go to mockups, I'm going to first look at the cooling distribution unit mockup. So a lot of this just goes into more detail based on the diagrams that I've been showing. I will switch it to light mode. Yeah, that reads better. Okay, so what you're looking at here, for folks who are not too familiar with Redfish, this is what's called the Redfish service route. It's the first thing a client finds when they look at a Redfish service, and it really shows the capabilities of the service and what's being managed. In here, what's of interest, since this is a CDU mockup, we want to look at the cooling equipment. So if you find cooling equipment in service routes, then you know that this manager is managing some set of cooling equipment, and maybe you want to inspect that in detail. In this case, within our cooling equipment resource, we see that it has some rack CDUs that we might need to monitor. So we step into that. And then we have a single rack CDU that is being monitored by this service. So we'll step into that. So at the first level, once you get to that piece of equipment, you see that you get things like your firmware version, the hardware version, production date, manufacturer model, serial number, all the fruit types of stuff that you might normally find on a sticker on the device. You have some general status that indicates the overall health and whether or not it's working. So we see that, yep, it's enabled and it's healthy. We have some location information to show where this might be physically located in your data center. And then we have the various types of subordinate resources to show what is within this rack CDU. So I mentioned we have primary loop connections. So if we go into there, we could see that there is one primary loop connection, and this goes to some chiller. So we know that we have a chiller in our data center that is providing the liquid for this rack CDU. We see that We get some information about some of the characteristics of the liquid. So we see that, yep, it's water. We get some flow rate associated with it. We have some valve control over it, so we know that the valve is 70% open. We get some supply temperature for the water, the return temperature, pressure associated with the loop. Very, I would say, simplistic right now. One of the pieces of feedback that we'd really like is, are there metrics associated with the liquid feeds into a CDU that might need to be reported outward? And to date, it's largely been temperatures and pressure types of metrics, but if there's anything else that's of use, that's good feedback for us. If we go through our secondary loop connections, we see that it has one output, secondary loop connection A. And this looks like it goes through some main rack that is called rack cooling loop A. And likewise with the primary loop, we get the same sorts of metrics. We know that we have some flow rate associated with the liquid. We get the liquid type. We get temperature readings for the liquid. We get all the pressure associated with it. We have our pumps collection, filters collection. So again, these are more types of devices that we might need to monitor, and maybe they're fruable, maybe they have part number, serial number, they may have firmware associated with it. In this case, we have some set point frequency for this pump. We have some power metrics associated with the pump to show how much power it's drawing. Given the amount of time left, I think I will I'll skip over a little bit. So in this case, one other thing to highlight would be, at least at the bottom, showing links. We show our facility in there. We show that, okay, this rack CDU is physically located in room 237. And if I follow that link, I can get some information about that physical room. I know that it's, in this case, it's located in Portland, Oregon. Okay. So I will move over to the UPS model. So again, starting at service route. In this case, since we're trying to find all our necessary power equipment, we want to look at the power equipment link in service route and follow that to discover the power equipment available. In this case, this service actually has multiple classes of power equipment available. We have some floor PDUs, rack PDUs, but because we're showing UPSs, we want to go to our backup power systems. So we step in there, we see we have one backup power system. And from here, like with that rack CDU, we have all of our FRU information, so all the sticker types of information you'll see, your part number, serial number, manufacturer, firmware, hardware versions, production date, the overall health of the device, physical location. And then if we go through the different types of resources available, we see we have a mains collection here to show what inputs are going into the rack PDU for powering the equipment. We see our branch circuits and outlets, so we can actually look at what types of equipment are being powered by this device, so likely computer systems. Lots of outlets on this one. So if we step through and look at one of these outlets, we see it goes to branch circuit A. And I don't think there are any computer systems shown in this mock-up. So it's just showing the power equipment view of things. So if we step back to the overall UPS, We also see that we have this new energy storage collection. We see it has a set of batteries associated with it, so there's a grouping of batteries in here. In this case, it's just one battery module within the UPS. And we have information about what that battery is capable of, what its current state is. We see that, if we go over to the UPS in question, we see that we can find its physical location, the UPS. We have our part information about the module, so part number, serial number, all the normal fruit types of information. We have some indicators available, so if you need to set a blinky light to mark a device for replacement, that's there. We also have some general health, so showing the overall state of health, charger state, so if the battery's not currently discharging or charging, we show that here. And it also has a couple of actions, so you can invoke things like internal self-test or self-calibration. The last thing to show in here would be the electrical converter. So if there's any types of internal equipment that you need to monitor and manage, there's very little in the proposal today. It's largely just classifying the types of equipment inside the box that might be of interest. This is an area where we need a lot of feedback from to see what is of use, what to be monitored. Okay. All right. So I want to end with this with a call to action. So we'd like folks who are interested in manageability of these types of devices to join the DCF workstream to help complete the Redfish models. As you've seen, there are some gaps. We don't have an answer for how leak detection is to be reported within a cooling device. We have some open ends for how deep the model needs to go. So do we really need to go so far as to show the different pieces of electrical converters in the appliance, in the UPS model? Can we simplify things? So having that sort of feedback for usability would be great. If you want more information on Redfish, dmtf.org/standard/redfish is where you can get all the main specs and papers that we publish. The Developer Hub is provides more educational material. And if you have questions, you could join the public-facing forum, so redfishforum.com. You could sign up, post questions, and we'll answer that. Other than that, if you have any feedback, using the feedback portal will be great. So that way we get notified if there's things that need to be changed in the model. All right. Well, thank you. Are there any questions?
Yeah, I just have a quick one.
Sure.
This may be a naive question because I'm not familiar with Redfish.
Mm-hmm.
Does that ever port into a dashboard somewhere where there's a graphical interface that displays that data, or do you kind of scroll through to get your data?
There's a lot of different applications that will look at a RESTful interface like Redfish and produce those types of GUIs and dashboards that show the red, green, yellow types of status. Some web servers on managers will generate their pages based on Redfish data. So largely, Redfish starts at that programmatic level, and you can build client applications to create those types of dashboards. Yep.
So how much of this is an investment by the component provider, like the CDU or the UPS, and how much is the investment on the data center team that installs, deploys, and maintains? That wasn't clear to me from the presentation.
From an investment, you mean resources for defining it?
Yeah, defining, building
Okay.
models.
Largely, in terms of who needs to own the pen on creating the models, I know the DMTF has largely volunteered to help with the deep technical detail for creating the schema definitions, incorporating that into the standard. Largely, if we can have documentation for what makes sense to report outward, do those relationship diagrams that we showed, do they make sense to the subject matter experts? We can take that feedback and do most of the work within the DMTF ourselves.
I think what might help from a DCF standpoint is
Mm-hmm.
a case study with actual UPS. I don't know if you have early adopters who are volunteers. I think that's what's going to flush out the detail.
That would help. We do have some member companies who work in this space and are trying to give us that type of information. Having a more complete picture would be very helpful for making sure that what we're doing internally makes sense.
So could you introduce those member companies to DCF so we could include them in a white paper or some form of case study?
Yeah, we can reach out for that. No more questions? Okay. Well, thank you.